Welcome to Math Mentor Media. In this video, Integrals Part 2 of a series about solving integrals, we will explore a technique is called substitution, and we will also see 3 examples of it in action.
We first take a look at the technique itself. It is used in situations where our integral consists of a combination of a function and also its derivative. This combination is often a multiplication of both. Classic ones are combinations of well-known trigonometric functions such as sine and cosine, as we will explore in example 1. Also, fractions, mostly simple, do apply, as we will see in example 2. Lastly, if we spot power roots or powers in itself, there is a decent chance substitution will work, as we will discover in example 3. As soon as we spot a function and its derivative combined in our integral, we then substitute this function denoted here by fx as a whole into a new variable, in this instance u, but you can choose whichever symbol you please. Next, we compute its derivative and multiply it with dx. This is called the differential of the function fx. And we equalize it with the differential of u, which is simply d do. We now are ready for the real substitution and replace our chosen substitutions in the integral we wish to solve. In most cases, this will make the integral easier to solve or give us immediately a basic integral which we can solve, as we have seen in part 1. Whenever we get stuck or the substitution made our integral worse or more difficult, we can always try again with another substitution. Let's take a look at our first example. We observe that the given integral is a combination of sine and cosine functions. So we know that substitution is a viable option. We also know that the derivative of sine is cosine, and the derivative of cosine is minus sine. We opt for cosine in this case, but could also have gone with sine as the function we initially want to substitute. After we have written down our substitution and its differentials, we start the real substitution. I have color-coded what gets replaced with what for an easier view of the situation at hand. After the substitution, we have a simple basic integral which can be easily solved with the power formula, as we have seen in part 1. We now have found the final solution, and as always, do not forget to add a constant uppercase letter C to the solution. In example 2, we see a fraction or a so-called rational function. Later down the line, we will see a technique for any rational function. However, whenever we can solve an integral with a simpler technique such as substitution, we prefer to do so. When we solve fractions with substitution, it is often best to choose the denominator of the fraction as the function we wish to substitute. This is especially true if the denominator of the fraction equals fully or partially the derivative of the denominator. Substitution will then lead to a simple basic integral solvable with the ln formula. Lastly, we explore example 3, which is also a fraction, but consisting of square root terms. Once again, it is best to choose the denominator as the function we wish to substitute, even though the derivative of it is no part of the denominator. However, and this is very important, it is possible to rewrite our substitutions. As we see, our first substitution formula is rewritten in green, and our second one in blue. Both these can then be used for replacing part of our initial integral more easily. After having done this, we have to work out and simplify our integral, but end up with basic integrals again. We also do not forget to replace our substitution back to our initial function and variable, and to add a capital C to the end solution.
If you like our content and want to learn more of these and other mathematical techniques explained by Math Mentor Media, be sure to click on the subscribe button below